This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at conservative vector fields and independence of path. So we're going to explore conservative vectors more. Now let's take a look at our first problem here. And guess I better bring my tablet up. There we go. Okay, so they show that the value of our line integral is the same for each parametric representation of C. I haven't been drinking, honest. So f is going to equal to xyi plus y squared j. And then for our first one, r sub 1 is equal to t plus 1I plus 6t plus 3j from 0 to 1. Okay, and they want us to find this right here. Basically, there's two parts to this. First, we have to find out what our f is equal to once we plug in our x of t and y of t. Now this is our x of t, and this is our y of t. So the f of x of t, y of t, we're plugging in t plus 1 for the x, comma, and then 6t plus 3 for the y. And I put brackets there, even though normally we put parentheses, but I just wanted to really separate these two, at least for the first one here. Well, this is x times y. So we're going to have t plus 1 times 6t plus 3i. Plus, and then we got y squared. So we're going to have 6t plus 3 squared j. Well, if I multiply these together, that's going to give us 6t squared plus 9t plus 3i. And if I square this, that's going to give us 36t squared plus 36t plus 9j. So that's our f. Okay, well, the next thing we need to find is this notation here, dr, that's a derivative of r. So we need to find r prime. So we've got r prime, and that's sub 1. Derivative of t plus 1 is 1, so we've got 1i, or just I. And derivative of 6t plus 3 is 6, so we've got plus 6j. Now this notation here means we find a dot product of them. So, and I'll shorten it. I'm taking the dot product of f and r prime, which is this right here and this right here. Now to find dot product, we're going to multiply what's in front of our i's. Well, there's an invisible 1 here. So 1 times 6t squared plus 9t plus 3 is just 6t squared plus 9t plus 3. And we'll multiply together what's in front of our j. So I take 6 times this. So we got 6 times 36t squared plus 36t plus 9. And that's going to give us 6t squared plus 9t plus 3 plus 36 times 6, 6, 1. Well, what would that give us? Let me get my calculator. 6, 3, 216? Yeah, 216. Normally I can do basic math better than that. 6 times 36t is 216t, and 6 times 9 is 54. Now combine together our t squareds, and we get 222. t squared. Combine together our t's. 9t plus 216t is 225t. And 3 plus 54 gives us 57. Okay. Well, what they're wanting us to do then is to find the integral. And we're going from 0 to 1. They already got that in the right form for us. And then we'll put this in here. 222t squared plus 225t plus 57 dt. And let me do it over here to the side so I'll make sure I have room. Well, add 1 to our power, divide by our new power. So we got 222 over 3 t to the third plus 225 over 2 t squared plus 57t from 0 to 1. Now if I put 0 in there, all those are going to drop away. So the only thing we have to worry about is 1. And if I put 1 in here, 1 to the third is 1, 1 squared is 1, and if I put 1 here, it's 1. So this becomes 222 over 3 plus 225 over 2 plus 57. And calculator. Where did I put the calculator? There it is. Save a little bit of time. 222 divided by 3 plus 225 divided by 2 plus 57. Enter, math enter. And that gives us 487 over 2 is our answer. Now that's part A. So let's go ahead and find part B. And it looks like we'll have room. Okay, part B. We got r sub 2. This is a vector. Equals 1/3 t plus 1/3 I plus 2t minus 1j from 2 to 5. Okay. Well, we're going to go through the same steps on this. This right here would be our x of t, and this right here is our y of t. So from our formula, we need to find f in terms of that. Now remember, f itself is equal to xyi plus y squared j. And what we're doing is we're plugging in the x of t and y of t. So I'm going to be putting x of t in here and y of t in here. Well, we'll plug this in everywhere we have an x, plug this in everywhere we have a y. So we're going to have 1/3 t plus 1/3 times 2t minus 1 I plus y squared, so we'll have 2t minus 1 squared j. 1/3 t times 2t gives us 2/3 t squared. 1/3 t times negative 1 is negative 1/3 t. 1/3 times 2t is 2/3 t. 2/3 minus 1/3 gives us 1/3 t. 1/3 times negative 1 is negative 1/3 I. And this squared gives us 4t squared minus 4t plus 1 j. Well, we also need our derivative. I won't put the sub 2 here, but well, I'll go ahead and put a sub 2. The derivative of this gives us 1/3, so we got 1/3 I. And derivative of this gives us 2, so we got plus 2j. Well, we need to find dot product of these two. So I'll find dot product of f and r prime. I won't put all the notation on it. So again, we multiply what's in front of our i's. So I multiply this times 1/3 And we'll multiply what's in front of our j, so multiply this times 2. So we get, let me see, 1/3 try it again, 1/3 times 2/3 t squared plus 1/3 t minus 1/3 plus 2 times 4t squared minus 4t plus 1. And I'm running short of room here. So let me simplify it over here. 1/3 times 2/3 gives us 2/9 t squared. 1/3 times 1/3 gives us 1/9 t. 1/3 times negative 1/3 is negative 1/9. 2 times 4 is 8 t squared. 2 times negative 4t is negative 8t. And 2 times 1 is 2. Combine these together, the t squareds. 8 times 9 is 72, plus 2 is 74, so we got 74/9 t squared. 1/9 t and negative 8t. Negative 8 times 9 is negative 72, plus 1 is negative 71. 9 t. Negative 1/9 plus 2. 2 times 9 is 18, plus a negative 1 is 17, so 17/9. And now we're ready to find our integral. And we're going from 2 to 5 of 74/9 t squared minus 71/9 t plus 17/9 dt. Now I'm out of room here, so I'm not going to do this by hand. This is kind of Calc 1 anyway. Find an integral of that. So let's do it on the calculator. So I'm going to press y equals clear. 74/9, 74 divided by 9, x squared, minus 71 divided by 9, x, plus 17/9. And then I'll do second trace, and choose number 7, our one looks like integral. And we're going from 2 to 5. So it comes up for the lower limit, I'll put in 2. Upper limit, I'll put in 5. And this gives us 243.5. Now I don't know of any good way of switching that to fraction, but if I exit out, and I do 243.5 math, enter, I get 487/2. Which, if we go up and compare that, that's what we came up here. So what they're trying to demonstrate here is, if you remember the previous lesson, when we found different setups here, it doesn't matter. It will still give you the same answer when you go and find the integral. So let me save this. This is conservative vector fields. And conservative vector fields, page 01.pdf. Okay, that's quite a bit of work. We're going to see in a little bit here that there's an easier way. Now our second problem, we're going to determine whether a vector field is conservative. Just refresh your memory on that. We saw that back in previous lesson. But here we're going to actually use it. Well, we did in the previous lesson too, but 20x, we're going to use it more extensively. Y to the third I plus 15x to the fourth y squared j. Now remember, what's before our I is our m, and what's before our j is our n. And to determine whether they're conservative or not, you need to check these partial derivatives. So partial of m with respect to y. Well, the 20x to the third just remains, and derivative of y to the third is 3y squared. So that becomes 60x to the third y squared. And then we'll take the partial of n with respect to x. That's this right here. Well, the 15 and the y squared remain. The root of x to the fourth is 4x to the third. 4 times 15 gives us 60. X to the third, y squared. If this and this are the same, that means they're conservative. So it says determine whether it's conservative. The answer here is yes. Okay. The fundamental theorem of line integrals. It says let C be a piecewise smooth curved line in an open region R, and given by R of t is equal to x of ti plus y of tj, with t being from A to B. If f of xy is equal to mi plus nj is conservative in R, that's key, it's got to be conservative, and m and n are continuous in R, so there's no place where they're discontinuous. Now R just represents your real numbers. Then our line integral, and there's two different parts here, but the important part is this last part. We can directly plug in our numbers and get our answer. But that's where f is a potential function of f. That is, f of xy is equal to del f of xy. Okay, well, let's see this in action. And I think you'll appreciate the simplicity of it. Okay, so we got y to the fifth. This is in differential form. Dx plus 5x y to the fourth dy. First thing, we got to determine if it's conservative. Well, this is our m, and this is our n. Partial of m with respect to y would give us 5y to the fourth. Partial of n with respect to x, 5 and y to the fourth remains. Derivative of x is 1, so that gives us 5y to the fourth. Again, since these are both 5y to the fourth, then it is conservative. So we can use the fundamental theorem. Okay, well, if we come back to our fundamental theorem here, you see we need to find our potential function. So that's your first step. Besides this being m, this is also f sub x. And this one is f sub y. This part right here that's before your dx will always be your f sub x, and 5x, or the whatever before your dy, will always be your f sub y. This is partial with respect to x, partial with respect to y. So going backwards, to find f, our potential function, we're going to take the integral of y to the fifth with respect to x, because that's what we've got here is the x. For the other one, to find our potential, we're going to take the integral of that with respect to y. Again, because it's our partial with respect to y. Well, this one here would give us x y to the fifth. And we ignore the k here, and we'll see why in a minute. And then the integral of this with respect to y, we add 1 to our power. We got y to the fourth. We add 1 to our power, becomes y to the fifth, and we divide by 5. So we got 5x times 1/5 y to the fifth. 5's cancel, and we got x y to the fifth. Now to find our function, what we do is we merge together these two right here. And if any of them repeat, see how these both have x y to the fifths? We don't write it down twice. So our potential function is x y to the fifth. Okay, that's this first part. You find your potential function, and then up here we got our this right here. Oh, it's a little bit a little bit confusing when you look at this. See, we need our x of and y of, and they're going to actually correspond to what we already have. So we got our x of t is going to equal to, and our y of t is going to equal to. Now we don't have this notation here. We don't have the r equals, for example. So when we're doing this, you kind of skip over that step. We can know f of x, y, and it's going from 0, 0 to 3, 2. So we're going to put in 3, 2, 0, 0. And it's a little bit, like I say, confusing when you look at this, because it looks like, well, you have to have r, and that's where you get your x of t and so forth. But if you don't have those, then you just plug in your numbers, because these right here is where the numbers are already done. We'll see that. We'll see one with an r, so the formula makes sense later on. Don't worry about the r for now. In other words, so this is our x and this is our y. So we'll put 3 in for x into our function. So we're going to have f of 3, 2 minus f of 0, 0. And again, that's our x and that's our y. So it's very, very straightforward in that regard. Well, x is 3, so we've got 3 times y is 2, so we've got 2 to the 5th, minus, and x is 0 times y to the 5th, so 0 to the 5th, and that drops away. 2 to the 5th is 32, and we've got 3 times 32, which gives us 96. And that's our answer. So this one is a little bit easier, because we didn't have to worry about the r part. So if you're given the points directly, and you find your potential function, you just plug them in and subtract them. So we'll go ahead and save that. Almost been nice if they had two formulas, one where you're given the points and one where you're just given r. There we go. Let's look at our next problem. Number 4. Now you kind of noticed in that previous one we ignored the stop in between. We didn't worry about 1, 3 at all. We just looked at our beginning and our ending, and that's what this fundamental theorem of the line integral says. So let's look at this one. And this goes from, let's see, 3x minus y plus 4 dx minus x plus y minus 5 dy. And we're going from the point 0, 1 to 3 e to the third, assuming it's conservative. Well, again, this is our m, and including the negative out in front, this is our n. So partial of m with respect to y. This is what we're checking here, the formula at the bottom. Well, the derivative of this, partial derivative with respect to y gives us negative 1. Partial of n with respect to x. Well, the derivative of x is 1, but remember we have the negative out in front, so that gives us negative 1. So, yes, we can use the fundamental theorem here. Okay. Let me go back up to our fundamental theorem. And it says we need to find our potential function. So, find our potential function. Well, this, besides being m, this is also f sub x, partial with respect to x. And this is f sub y. So, for this one, to find f, we're going to take the integral of 3x minus y plus 4 with respect to x. And on this side, we'll take the integral of negative x minus y plus 5. I carried a negative through with respect to y. So for this one, with respect to x, that gives us 3/2 x squared minus xy plus 4x. And this one, with respect to y, gives us negative xy minus 1/2 y squared plus 5y. Now, normally we put the plus k here, but our formula says we're going to subtract these. If I had a plus k on the end of both of these, would have k minus k, which would drop away anyway. That's why you don't need to worry about the constant when finding the potential function of these. Okay, now our function, we now need to merge these together. Now anything that's repeated, you only put down once. See how they both have an xy? A negative xy, I should say. So we're only going to write that down once. So we got 3/2 x squared plus 4x minus 1/2 y squared plus 5y. And then what they have repeated, minus xy, we only put down one time. Okay. Now we're going from this point to this point, or well, from this point to this point. So you put your ending one first. So we got 3e to the third, and over here we'll put in 0, 1. So we're going to plug these into our function. So it's like this becomes f of 3e to the third minus f of 0, 1. Okay. This is our x, and this is our y, and this is our x, and this is our y. So we're going to have 3/2 times x squared, so we're going to have 3 squared, plus 4 times x, which is 3, minus 1/2 times y, which is e to the third squared, plus 5 times y, which was e to the third, minus xy, so 3 times e to the third. Minus, now put parentheses because that's affect everything that follows it. We'll put this in for x and this in for y. So we've got 3/2 times 0 squared plus 4 times 0 minus 1/2 times 1 squared plus 5 times 1 minus 0 times 1. Now let me double check that. 3 squared plus 4 times 3 minus 1/2 e to the third squared plus 5 times y minus 3 times, where'd that come from? Oh, that's x times y. So x times y. Okay. And all of those will drop away because the x is 0 except for the y portions. Okay, that looks correct. Well, 3 squared is 9 times 3 is 27. So we got 27 halves. Plus 4 times 3 is 12, minus 1/2 e to the 6, plus 5e to the third, minus 3e to the third, minus, the zeros drop away, 1 squared is 1 times negative 1/2 is negative 1/2, 5 times 1 is 5. Okay. Equals 27 over 2 plus 12 minus 1/2 e to the 6. 5e to the third minus 3e to the third gives us 2e to the third. The negative flips the sign of everything and follows it, so it becomes a plus 1/2 minus 5. Now 27 over 2 plus 1 over 2 is 28 over 2, which is 14. 12 minus 5 is 7. Minus 1/2 e to the 6 plus 2e to the third, which gives us 21 minus 1/2 e to the 6 plus 2e to the third. And that's our answer. And you see it's still a little bit of work, but not as hideous as before. So let's save that. And let's look at our next problem. Find a value of the line integral, and we've got this right here, 4xy dx plus 2x squared plus 2y squared dy. This is our m, and this is our n. And take the partial of m with respect to y, which would give us 4x, and partial of n with respect to x, and that's going to give us 4x. So we can use the fundamental theorem of line integrals here. Well, this is not only m, but it's a partial with respect to x, and this is a partial with respect to y. So f, we're going to take the integral of 4xy with respect to x, and over here f will be the integral of 2x squared plus 2y squared with respect to y. So this one, with respect to x, scratch my ear there. With respect to x, the x becomes 1/2 x squared, so this becomes 2x squared y. Now over here, with respect to y, this doesn't have a y in it, so this just becomes 2x squared y. And this one becomes, add 1 to your power divided by your power, that becomes 2/3 y to the third. So again, to find our potential function, we merge these two together, and anything they have in common we only write down once. They both have a 2x squared y, so we'll have a 2x squared y plus 2/3 y to the third. Now we're going from 3, 0 to 0, 2, so we're going to take 0, 2, and then we'll also plug in 3, 0. Your ending one goes first minus your beginning, and we set it up this way: f of 0, 2 minus f of 3, 0. And again, this is our x, this is our y, this is our x, and this is our y. And we're going to plug that into our potential function, which is our f of xy. So x is 0, so we've got 2 times 0 squared times y, which is 2, plus 2/3 times y, which is 2 to the third, minus, I'll put parentheses because that's affect everything that follows it. X, we got 2 times 3 squared times y, which is 0, plus 2/3 times 0 to the third. Now these zeros over here cause all this to drop away. This 0 here causes this first part to drop away. 2 to the third is 8, times 2 is 16. So our answer would be 16/3. So let me save that. And let's take a look at this. This I copied straight out of our previous lesson. This is a test to see if when you got the 3 dimensions in there. This is a test, and I didn't mean to put all that, I guess, but this is a test to see if it's conservative. We'll come back and look at that. Let's take a look at this problem. Okay. Want to find our line integral again. And f is equal to 3i plus 2zj plus 2yk. And we'll get to this in a minute. But this is going to be our m, this is going to be our n, and this will be our p. And let's go back up here. Things we want to check. Partial of p with respect to y. So we want to check the partial of p with respect to y. Well, here's y. The partial derivative of this with respect to y would give us 2. And we want to compare that against partial of n with respect to z. So partial of n with respect to z. N is right here with respect to z would give us 2. So these check. They're both equal. That's the first condition. Second one, we need to find a partial of p with respect to x. So partial of p with respect to x. There is no x here, so that'd be 0. And we're comparing that against partial of m with respect to z. So partial of m with respect to z. Well, there's no z here, so that's 0. So that checks. We've got one more. Partial of n with respect to x. Well, there's no x there, so the derivative of that is 0. And partial of m with respect to y. I apologize, I should have cleaned that slide up a little bit. But there is no y here, so that'd be 0. Since all of those are equal, then this is conservative, and we can use the fundamental theorem of line integrals on it. Okay. Something's wrong here. Before we find our partial or potential function, and then we plugged in our points. We don't got points. We're given r of t. And remember how I said it's a little bit confusing because like the first part of that's done for us. So let me write that down. R of t is equal to cosine ti plus sine t j plus t squared k. Okay. And go back up here now. We just determined it's conservative. We have a k, but same idea. And then we got our r here, which gives us our x of t and y of t. I think what I'm saying, x of t and y of t. Well, they tell us in this problem that t is from 0 to pi. So we got t is equal to 0 and t is equal to pi. Think what these represent. This is x of t. This is y of t. And this is z of t. So to find our points, we can just plug in these t values. So x of 0 is going to equal to cosine of 0, which is equal to 1. Y of 0. And we can plug 0. The t is equal to 0. We'll plug 0 in for the t. So we've got sine of 0, which is 0. And z of 0. We've got t squared up here, so we'll have 0 squared, which gives us 0. So this first point is 1, 0, 0. The second one, we're going to plug in pi. So we got x of pi, which is cosine pi, which is negative 1. We got y of pi. That's equal to sine of pi, which is 0. And we got z of pi, which gives us pi squared, the t squared. So this point here then will be negative 1, 0, and pi squared. So it's going from this point to this point. So now we have our points. We need to find our potential function. Now remember, up here, besides this being m, n, and p, this is our partial with respect to x, this is our partial with respect to y, and this is our partial with respect to z. So let me write those down now. Partial with respect to x is equal to 3. Partial with respect to y is equal to 2z. And partial with respect to z is equal to 2y. Okay, now let's find our potential function. And then we just plug in those points and we're done. Well, to go backwards. To find f here, we're going to take the integral of 3 with respect to x. So that's going to give us 3x. Here, to find f, we're going to take the integral of 2z with respect to y. That's going to give us 2yz. And for this one, we'll take the integral of 2y with respect to z. So that's going to give us 2yz. Okay, so for our potential function, we want to merge these three together, and if any of them repeat, we don't want to write them down twice. And you see I got 2yz here and I got 2yz there. So our potential function is going to be 3x plus 2yz. Okay, now we need to plug in our points. And so we're going to plug in this point, -1, 0, pi squared, and 1, 0, 0. Now, you see I put in the notation here of f of xy instead of f of xyz. I'm not sure I'm really comfortable with that. It came out of a test bank that way, where it always would write it this way. Now I'm not sure if it's just an error in test bank or so forth. I've only taught Calc 3 once, so I'm thinking it should be f of xyz. I think it's an error in that test bank. But anyway, we plug these in. This is our x, y, and z, and this is our x, y, and z. So we got 3 times x, which is -1, plus 2 times y, which is 0, times z, which doesn't matter since y is 0, minus, and plug this in for x, so we got 3 times 1, plus 2 times 0 times 0, which gives us -3, that drops away, and that drops away, and we got -3, which ends up giving us -6. So let me go ahead and save that. And let's look at our next problem. Now this doesn't say determine is conservative. It says directly evaluate the line integral. So we can assume that since it's in that section that they're conservative. At least that's the way the instructions read. Even if they weren't, though, if I looked at it, this is our m. Partial of that with respect to y would be 7. And this is our n. Partial of that with respect to x would be 7. So it's definitely conservative. Well, this right here is going to be our partial with respect to x, and this is a partial with respect to y. So to find our potential function, here we're going to take the integral of 7y with respect to x, which gives us 7xy. And over here we'll take the integral of 7x with respect to y, which gives us 7xy. Now again, whatever the variable is here is what we take it with respect to. Whatever the variable is here is what we take it with respect to. Now our potential function, we merge these together, and if any of them are repeated, you don't write them down twice. They both have a 7xy, so we just put 1 7xy. And this is going from our ending value for goes first, and then our beginning goes here. So smooth curve from 0, 0 to 2, 4. So we're going to have 7 times 2 times 4 minus 7 times 0 times 0, which gives us 56 as our answer. Okay, let me save that, and then we'll do the last problem here. Go 8. We got f of xy is equal to 12 x to the third y to the third I plus 9x to the fourth y squared minus 1j, and from the points P to Q, so direction is going like that. And it says find the work done by the force field F in moving an object from P to Q. Well, first let's determine if they're conservative. If it's not conservative, you have to find the line integrals like we did in the last lesson. or the first problem we looked at. This will be m, and this will be n. So partial of m with respect to y. The 12x to the third remains. The derivative of y to the third is 3y squared. So that gives us 36x to the third y squared. Partial of n with respect to x. The 9 and the y squared remain. Derivative of x to the fourth is 4x to the third. 4 times 9 is 36. X to the third, y squared. And the negative one drops away. So these are equal. So we can use the fundamental theorem of line integrals. Now besides this being m, this is again a partial with respect to x, and this is a partial with respect to y. So for this one, we'll take the integral of 12x to the third, y to the third with respect to x. And on this one, we'll take the integral of 9x to the fourth, y squared minus 1 with respect to y. Well, the 12 and the y to the third remain. The derivative of x to the third is, or integral. Sorry, I'm watching Big Bang Theory. I should be focusing on this problem. But this is 1/4 x to the fourth, so that gives us, actually let me write to step out. I'll screw it up. Watching TV while I'm doing this. Should be ashamed. Okay, 12 divided by 4 is 3, so we've got 3x to the fourth, y to the third. Now for this one, we're going to have 9x to the fourth times 1/3 y to the third minus y. 9 divided by 3 is 3, so we've got 3x to the fourth, y to the third minus y. So our potential function, we want to merge those two together. Anything that's repeated, we only write down once. They both have a 3x to the fourth, y to the third. So I'm just going to put that down once. And then minus y. And then it's going to go from, well, it's from 0 to 0 to 2 to 3, so we'll put the ending one first, and then we'll put 0, 0 over here. So we're going to have 3 times 2 to the fourth, 3 to the third, minus y, which was 3. This is our x, and this is our y. And over here, we got minus. If I put zeros in for everything, I got 3 times 0 to the fourth times 0 to the third minus 0. All that drops away. Let me plug this in my calculator. 3 times 2 to the fourth is 16 times 27 minus 3. Gives us 1293, assuming I typed it in correctly. And that would be the work done. I'll go ahead and save that. We got a couple more slides we'll talk about, but I don't have any problems on them. Some of them just kind of make sense when you think about it. Okay. Independence of path and conservative vector fields. If f is continuous on an open connected region, then the line integral is independent of the path if and only if f is conservative. So it's saying if it's conservative, then we don't have to worry about it's independent of the path. You remember how we're only concerned with the beginning point and the ending point? We don't care about anything in between. So it doesn't matter, what points we're going through to get there. For our line integral. Now, equivalent conditions. Let f f of x, y, z equals mi plus nj plus pk have continuous first partial derivatives in open connected region R. And let C be piecewise smooth curve in R. The following conditions are equivalent. F is conservative. Then the line integral is independent of the path. And the line integral is equal to 0 for every closed curve C in R. Because if you think about it, a closed curve means that your beginning point is the same as your ending point. Which if you went through all of it and plugged in those, you should get 0. So again, some of this makes sense. I'm not sure if the independent of the path kind of makes sense, but then this is conservative, kind of goes right along with it. And conservative vector fields and independence of path. So I'm going to go ahead and save this movie.